Starting with factoring. Line here, black, factoring in black. If this can be factored, this is actually one of the easiest ones in the world to factor, because the 5x squared as your first one gives you only one option of 5x and x. So no thinking involved. Only one option. When you look at your last, oh no, this isn't the easiest one ever. I was thinking of another one. I thought the last one was going to be a 1. It's not the easiest ever. It's a 6. It's actually a little bit more complicated. So now with the 6 we have options. 1 and 6, or 2 and 3. Or 6 and 1 and 3 and 2. We have to make our outside and our inside make 13. And this one's extra difficult because you can make 13 in 2 different ways. You can make 13 adding or subtracting. The minus actually tells you you should use subtracting as an extra hint. I don't know if any of you ever used that extra hint. But the minus 6 means I need to subtract. So the 3 would have to go here and the 2 here. So my outside is 15, my inside is 2. 15 minus 2 is 13, but I would need a plus 15 and a minus 2 to make that work. And then your answers are 2/5 and -3. If you can factor, it's usually the easiest way to solve, as we'll see when we do the completing the square and later the quadratic formula. So a review of completing the square. We'll switch to green. When we solved equations completing the square, we moved the 6 over to the other side, and then we divided everything by 5. We get fractions, left a space, left a space. And the 13 over 5 is a hint that it would be 13 over 10, half of 13 over 5. And then when you square 13 over 10 and 13 over 10, you'd add 169 over 100, which means you have to add on the other side exactly the same thing. So a little bit different than when we can use completing the square for changing to standard form. This is a review of using it to solve. You need a common denominator. So in this case, 6. Oh, and I forgot, this has to also, right, when I divided everything by 5, that would get divided by 5 as well. Get a common denominator of 100. You're going to just trust me when I add these together. After I made a bunch of mistakes, you're like, yeah, we don't trust you anymore. You're going to get 289 over 100. Now, this would be a calculator question because I don't know how many of you know the square root of 289. It's plus or minus when you square root both sides. It's 17. You get plus or minus 17, and the square root of 100 is 10. Okay. And move the 13 over 10 over. And this will give you 2 answers. When you do plus 17, you're going to get 4 over 10, which reduces to 2/5. And when you do minus 17, minus 13, minus 7 gives you -30 over 10, which reduces to -3. And we get the same answers from factoring, but I think observing, you're like, ooh, I wish I was good at factoring because that looks a lot easier. And then the quadratic formula method, that's just plugging things in. So you go x equals -b, which is -13, plus or minus b squared is 169 minus 4, a is 5, and c was -6, all over 2 times a. Add those all together, you get 289 over 10. And we already figured out that the square root of 289 was 17. Adding gives you 5 over 2. Subtracting gives you -3. So all methods give you the right answers. Oh yeah, I did. Look at that.
Mental math.
Mental math. 2/5. And x equals -3. So we get the same answers with all three methods. The green and the blue method would probably mean you need a calculator. So if it was on a non-calculator part, you would have to know how to factor. But if it's non-calculator and you didn't know how to factor, you could struggle through the bigger numbers without a calculator. What we're going to do today is look at what happens if we change this from an equal sign to being an inequality. Less than, greater than, less than or equal, or greater than or equal. So if you turn to page 341, they have quadratic inequalities in one variable. It's called a quadratic inequality because the highest power is an x squared. And you have all of these options. And what I'd like you to do on the side, right beside this box on page 341, is we're going to write some notes for how to solve quadratic inequality. Step 1. Just like a quadratic equation, make one side equal to 0. Then step 2, we are going to actually pretend it equals 0. And solve it just like we did in chapter 3, either with the quadratic formula, or completing the square, or by factoring. And you'll find that most of them in this chapter, you can actually factor, because they like to use nice numbers, so then they avoid the quadratic formula. So for the most part, they're going to factor. So up till now, this has just been a review of chapter 3. The new step is step number 3. In step number 3, we are going to make a number line maybe I'll say with there we go. With your solutions or your x-intercepts and we're going to use test points to find where it is true and false. This is a new step, and we'll do an example and it'll help you understand what this is talking about. And then finally, you're going to write your solution, and you can either use set notation or interval notation, which you used in grade 10. Remember when you did domain with set notation and interval notation? Yay, so exciting we get to use those again and review those. Yeah, all those fancy brackets. So we're going to start just by analyzing what this could look like and figure out through sort of guessing and checking, we'll find an answer. And then we'll look at how does these steps help us streamline it and make it a little bit easier. So, we're going to start off with x squared minus 9 is less than 0. And we're going to put values in this side that are true and put values in this side that are false. So if you pick a random number, you will get a correct answer. It'll either fall in the true category or the false category. So, Audrey, pick a random number.
-4.
-4 starts us off with a negative, right? Makes this work extra hard. If you plugged in -4 for x, is the answer on this side less than 0? Well, -4 squared would be 16, positive 16. 16 minus 9 would be 7. Is 7 less than 0? No. So we would put -4 on the false side. Aaliyah, pick a number. 6. If you plugged in 6, 6 squared is 36, minus 9 would be 25, no, 27. Is that less than 0? No. So 6 would go on the false side. Anybody think they can find a number that's true? 2. Plug in 2, 4 minus 9, yes. 2 works. Anybody find another one? -2 also would then work, right? Because when you square positive or square negative, it works out to the same thing. 0. 0 minus, yeah, that works. There's a lot of numbers that work. How could we categorize the numbers? If I said, what are the numbers that are going to work? And you would say, they would be all the numbers between what and what? 3 and -3. But does 3 actually work in this case? No, we would have to put 3 on this side and -3 on this side because it would make it equal to 0.
Yeah.
But we could say that based on our observations, our solutions is everything between -3 and 3. This would be interval notation. When you want to write things in between, in set notation, it would look like that. X is in between -3 and 3, or the interval goes from -3 to 3. We use round brackets because it's not included. So now we're going to look at how would we do this with the steps. Step 1 says make one side equal to 0, already done. Temporarily pretend it is equal to 0, and solve. Probably if you solve this, most of you would what? Move the 9 over and square root both sides and remember the plus or minus 3. And the plus or minus 3 is important, right? Because that's where it was equal to 0. That's where it changes. Now, in step 3 that we wrote down here, we said make a number line with your solutions. So we're going to make a number line with our solutions. We're going to put -3 and 3. It's important that -3 is to the left, right? If this was a number line. And we're going to find out that when there's we're going to put circles here. Sometimes we're going to fill them in. Sometimes we're going to not fill them in. This time we're going to leave them open because it didn't have an equal sign. -3 and 3 both fall in the false side. They don't work. And then we're going to do test points. And what you did here was test points. But when you find a test point that is false, like you plugged in 6 and it was false, it actually means this entire section, no matter what you plug in, bigger than 3. Does it make sense that that would always be false? Plug in 10. Yeah, false. Plug in 5. False. Plug in 8 million. 8 million squared minus 9. Is that less than 0? No. False. Anything between -3 and 3, you found that whole section already to be true. I would probably choose 0 as for mental math's sake, as a really nice test point. But anything in between there will always come out true. And anything less than 3, we tried a -4. That didn't work either. So this is the way that you can use test points to figure out if it's going to work. You can also think of it graphically. So you can use chapter 4 to help you with this too. If you think about the graph of x squared minus 9, you see the vertex is at 0, negative 9. It would be taking the x squared graph and moving it down 9 units. It would look like this. And if we're looking for where x squared minus 9 is less than 0, we're really looking at, that's y. Y is equal to x squared minus 9. Where are your y values less than 0? And you can see that on your graph, right? Here's minus 3, and here's 3. And all of this section here is where your y values are less than 0. So you can also use your graph to figure out false, true, false as well. Sometimes you'll like test points. Sometimes you're going to like your graph. One thing I'd like you to highlight at the bottom of, I'd like you to highlight this. I like these words. The x-intercepts of the graph are called the critical values. I like that critical values thing. Use it a lot in calculus as well. And maybe you want to put a note off to the side. On our number line, we're going to use open circle. Open circles when it's greater than or less than. Closed circles when you have the equal sign with it. Oh, I thought we'd get to example 1, but we'll have to start example 1 next week.